Guys, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video, Unit 8.5, because this is not a whole unit, it's just 2 days of notes. And it's going to be about roots and radical expressions. So the first part, warm-up, is just a refresher about what we've done before. So let's just do it as we've been doing. The square root of 16, what could that be? Plus or minus 4. Whoa, hold on, that's not what it's supposed to look like. Plus or minus 4, because 4 times 4 is... Right, and negative 4 times negative 4 is? 16. That's correct. Yeah, we did it. Now, I'm going to tell you something else real quick as well. You see the square root, right? There should actually be a number here. Do you know what number goes right here, this little number right there? It's called a square root. So what number do you think goes there? A 2, that's right. So what this actually means is that you should multiply a number by itself twice to get the answer. So that's how you find it. We take the number 4, we multiply it by itself twice, C2, and that gives you 16, right? So that's what it actually means right there. So on number 2, does anybody remember how to do number 2?
You do the ID?
Not on number 2. Okay, right, so one way you could break it, you want to break it down further because 32 is not a fully factored form. So Trey suggests to go square root of 8 times square root of 4. What is square root of 4? Plus or minus 2, right? Plus or minus 2 square roots of 8. But have we broken it down as far as it can go? No. Why not?
Because 8 can be simplified.
To what?
4.
Just 4?
2 times 4.
2 times 4, right. 2 times 4. So we can break the 8 down into square root of 4 times square root of 2. And what is square root of 4 again? So now we have plus or minus 2 times 2 square roots of 2. What's 2 times 2?
4.
So my final answer is 4 plus or minus 4 square roots of 2. And there you go. So notice how this took a couple of steps, right? But that's because you chose, your first breakdown wasn't the optimal way to break it down. However, it doesn't matter. As long as you go as far as you can, you'll still get the right answer. But what if I had chosen square root of 16 times square root of 2? Right? Because 16 times 2 is 32. What's the square root of 16?
4.
Plus or minus 4 square roots of 2. And look, I got the exact same answer. Just one way is faster. But you'll still get the same answer, okay? All right, now, number 3. Do you remember what to do when you have a negative under the radical? That's the I, yes. So, what do you do with the I, though? Put the I on the outside. What happens to the inside number? Becomes positive, all right, and then what do I do with that? What's the square root of 4?
2.
All right, because this is imaginary, we're not going to worry about plus or minus. It's because it's a made-up imaginary, in imagination land number, 2i. There you go. That's a non-real solution. All right, that's just warm-up, refreshing our memory. But now let's go into the kind of maybe things that you haven't heard before. First off, we need to do some vocabulary so we all know what we're talking about, right? When you read questions, you need to know what the question's asking. Okay? Because, sometimes people reading questions are like, I don't know what this word means. I'm just going to guess now because I have no idea what it's asking me. So it's very important that we know the vocabulary. All right. So that's a general format of an equation using roots and a radical, okay? So first of all, the index. Make sure you hear these terms and memorize these, okay? Index is the degree of a root. So which part of this equation do you think is the index? The n, very good. N is what you call, that's not very clear. N is what you call the index. Next, the radical is the root symbol. So that's very self-explanatory. It's this symbol right here. Don't call it a square root because it's only a square root when n is 2. All right, it's just a root, a radical. All right. And the radicand is the part that is under the radical. So what part is that? B, that's right. B is the radicand. And those are the 3 parts that you need to know, okay? All right, so next up is knowing how to read this kind of equation, okay? So it's very important that you know how to read it because when there are problems where they give it to you in words, and you need to write an equation, you need to understand how to change those words into the equation. And it goes in order. You see how the n is the first thing you see, right? So you say the n root of b is a, or equal to a. The nth root of b equals a. Okay, that's how you read that. So, just a quick example just to show you guys. How would you read this?
The fourth root of 16 equals 2.
That's right, the fourth root of 16 equals 2. Perfect. And so it's important to know this reading, because what if I ask you this? What is the fifth root of 32? How would you write that? 5.
Yeah, the square root.
Radical, not square root. Square root's a 2. The radical.
Well.
Radical, yeah. Radical, dude. The fifth root of 32 equals, and then that's what you're looking for. You're trying to see what it equals. 2. Yeah, because look, if this is 4, 2, and then we go to 32, let's just multiply by 2 one more time. All right, and now here's the big topic of debate right here, principal root. Principal root, when a number has 2 real roots, both positive and negative. For example, look at number 1 and number 2, right? There are 2 roots, positive and negative, right? Then the principal root is the positive version. Okay, the principal root is the positive version. Make sure you understand and remember that vocabulary word, because you're going to see that a lot. So if I asked you, what's the principal root of square root of 16? What is it? Positive 4. Very good. All right, that's what principal root is. It's just positive answers. Okay? So now let's take a look at some different situations. All right, this is going to help you figure out how many solutions you have, what kind of solutions you have. So if the index n is odd, right? If this little number right there, the index is odd, then that means you're going to have just one real root of b. You're only going to have one answer. That answer could be positive, maybe it's negative, but the thing is you're only going to have one. You won't have plus or minus, okay? So when the index is odd, there will just be one answer. And then also, you can rewrite that equation right there as b equals a raised to the nth power. Now, just on our test, you know, we had questions such as this. The fourth root of x equals 2. How would you solve this kind of problem? The fourth root of x equals 2.
X equals 2 to the 4th.
That's right. And that is the same thing as what we're showing here. B equals a to the n from our original equation, right? But now we've just replaced all of the letters with different numbers, right? So this is just showing you that's the technique that's going on right there from step to step. Okay, so now if the index is even, if n is even, and b, your radicand, is positive, then that means there's going to be 2 real roots of b, positive and negative version. Take a look at number 1. What's the index here? Is that even?
Yes.
Yes. And so is this a positive radicand?
Yes.
And remember, it just said, if that's the case, even index, positive radicand, you're going to have 2 real solutions, positive and negative. You see? Same with the second one. What's the index here? The index.
0.
If it's not there, then it's going to be 2, right? Because that's the square root. So the index is 2, which means it's even. This number is positive, right? Which means you're going to end up with 2 real roots.
So there's not one there, it's always 2.
Right, because when it's not there, that's just the square root, right? And square means the 2. Okay, so yeah, if b is positive, there's going to be 2 real roots. All right, now, if your index is even, but b is negative, that means you're going to have no real roots, or no solution, really. Because, look at number 3, right? The index is what on number 3? 2. And negative 4 is a negative number, right? How many real solutions did you have there? Is that a real number? No, so you had no real solutions, right? And so that's how you can break down these different situations, right? It's even, if it's odd, there's going to be 1 real root. If it's even index and a positive number under the radical sign, it's going to be positive and negative answer. And if it's b is a negative number, there's going to be no real roots or no solution. All right, so finally we can get into some examples. Fun time. So example 1, simplify the following. For even index radicals, give only the principal root. So make sure you read the directions. It says even index radicals. Which numbers, 1 through 6, have even indexes?
2, 5.
That's right, 2, 5, and 6, because those are the ones that have 4 as the index. That's an even number, okay? And it says for those even index radicals, give only the principal root. What does that mean? The positive, right, that's right. Okay, so example 1, or number 1, cube root of 8. What do you think the cube root of 8 is?
Plus or minus 2 to the square root of 4.
Whoa, 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 what? What?
Every 2 times 4 square roots, right?
Square root of 2 or square root of
No, so,
Change the equation to like b equals ax to 9.
yeah, okay, so you, yeah, so how do you want to change it to then?
It would be like a equals x to the third power.
A equals x, what is a then? A way that you can think about this intuitively right here, remember 3 tells you how many times you're multiplying a number by itself, right? So right here you're going to have a number multiplying itself 3 times. And that should equal 8. What number would that be? 2.
Oh.
So your answer is 2. And notice the index is odd, right? That lets you know that you only have one answer. It's just positive 2. There's no negative 2 wouldn't even be. 2 is the answer, yes.
Wait, how?
The cube root of 8 is 2. Yeah.
You have to find like a
2 times 2 times 2.
you have to find a multiple.
Oh, okay, never mind. I was, yeah. I was thinking 3 times 2.
You're trolling, okay. All right, number 2. We've got the fourth root of 16. So fourth root tells us that we're going to multiply a number how many times by itself? 4. So what number? 2, that's right. 2 times 2 times 2 times 2 equals 16. So your answer is 2. However,
How many plus 2 is positive 2?
it is, okay, so Trey brings up a good point. Technically, negative 2 would work as well because what is negative 2 times negative 2? It's still positive 16 because you're multiplying an even number of times.
So you want us to put plus or minus?
No, because, so, yeah, exactly. Trey brings up a good point. There are technically 2 roots, but then, as you say, in the instructions, it says principal root. That lets you know I only want the positive.
You just put positive 2 or you
You just put the 2. Yeah, no, you don't need to write like a plus in front to let it, it's positive. All right, number 3. What is the cube root of 125?
25?
5. Because how many times are we multiplying a number by itself?
5
Right, 5 times 5 times 5. Good, so the answer is 5. Very good. The numbers are relatively small because you don't have calculators. All right. What about number 4? It's just 1. That's right. The fifth root of 1. We're multiplying a number 5 times by itself. So 1 times 1 times 1 times 1 times 1 is 1. So what's number 5? 1. What if I asked you what are all the possible real roots?
Plus or minus.
That's right, because it's an even index, right?
Yes.
So originally you would have plus or minus, but because we're looking for principal, it's just 1. Okay, and the last one, number 6,
9 times 8?
it has to be a single number.
Oh,
Remember?
okay.
3 will be enough.
Ronnie got it. It's 3. 3 times 3 times 3 times 3. How many times did I say it? Anyways, yeah. This is, 81. So the answer is 3. And originally it would be plus or minus 3, but principal root, so 3. There you go. Flip the page over now. This is where understanding how to read your equations comes in handy. So, example 2 says, what are the real cube roots of the following? Why do you think it says real right there? Why would it let you know that?
So we have plus or minus.
So that way if you have plus or minus, you put plus or minus. However, it's asking for cube roots, and cube roots, if that's an odd index, right? It's a 3, so that means you're only going to have one answer. So that really doesn't apply here. Okay, so on number 1, what is it even asking me to do? Because these are just random numbers put out there. I don't see really an equation to solve. Like what? I need to write an equation to solve. What's the question asking me?
What are the real cubes?
So how can I write this into an equation?
Put the radical over it.
And then?
And 3?
Where?
Right there.
So 3 is the index? That's right, good. because you're looking for the cube root of these numbers.
Multiply that.
So what would the number be? What is?
002.
Okay, so I heard 0.002. Let's see here. 0.002 times 0.002 is, whoa, wait a second. And I got to do one more time, right? 0.002. All right, that's probably not the answer then. That's a lot of zeros. Does anybody know what the answer is going to be? 0.2.
Round it up. 0.02.
0.2 times 0.2 is, times 0.2 one more time is, that was right, is 0.2. All right, now I'm going to show you just a little kind of trick to getting this, to finding out that it's 0.2. Do you know what multiplies by itself 3 times to get 8? It's 2, right? But look, how many decimal places do you have here on the 0.008?
2, 3.
3, right? 1, 2, 3. Okay? When you multiply 0.2, how many decimal places is in this 0.2 right here? Okay, but now I have another one, so how many total now?
2.
Then I have another one, how many total? So that's the 3 that you need to get to.
2 times 4 and 4 times 2.
Yeah. But you need 3 decimal spots, that's why you put 0.2, because each of those,
Positive 0.2, right?
that's right, it's positive.
Because odd.
Exactly. Well, not just because it's odd, just because positive times positive times positive is a positive 0.08. Because if you were to do negative times negative times negative, what does that come out to be? Negative times negative times negative
It's negative. Oh,
is negative, that's right.
Oh.
Yeah, that's why there's only one answer, because both don't work. Only one works. All right, what about number 2, though? We got the,
Radical 4 and then 3 outside.
right,
The answer
equals.
is
Wait, why is it 3? It's cube.
The question. Read the question. What are the real cube roots of the following?
square roots. Oh.
Right. So what is the cube root of negative 1,000? What do you think?
20.
15.
Negative 10. 25.
All right. So I heard 10 and negative 10, and the answer would be negative 10 because remember we need to have it equal negative 1,000, right? Positive 10 times positive 10 times positive 10 is,
Oh, negative.
what's a positive times a positive times a positive?
How many?
Is this a positive in here?
No.
No. So we need the negative.
Positive times
No, you can't change the signs.
Negative times negative. It'll be like, it'll be 10 times 10, that'll be positive.
Right. So it has to be a negative number.
Times a negative 10 will be negative.
Exactly, which means it's negative 10. Negative 10 times negative 10 is 100, and then 100 times negative 10 is negative 1,000. See? All right, the last one over here, number 3, 1 over 27. What do we do here?
Do you want to like multiply it?
What do we need to do first with to make it into an equation that we're trying to find?
You want multiply it? Put the radical over it?
Radical over, yeah, because first we're trying to see what we're doing here. And then?
Push it up.
The 3? Okay. So, does anybody know the cube root of 1 over 27? What is the cube root of 1 over 27? That's what it's asking.
You do 1 over 3.
That's correct, actually. Ronnie's right. It's 1 over 3.
Oh, wait. Oh. Now I know.
Why is that? Because 1 over 3 times 1 over 3.
9 times 3.
Right. When you're multiplying fractions, remember, you just multiply straight across. So straight across the top is 1 times 1 times 1, which is?
1.
And straight across the bottom is 3 times 3 times 3, which is? That's right. And that is what you have as your radicand. So 1 over 3. Yes, there can be fractions. All right, example number 3 then. Here we go. What are the real fourth roots of the following? So the question is a little different here.
So radical.
Radical,
Just put the 4 on the outside.
4,
Negative 1.
negative 1. What?
I mean, negative 0.1.
Negative 0.1. Well, let me check. Let's just check signs here real quick.
You said science?
Signs.
Oh.
So I'm not even going to use a number. I'm just going to show you by signs. Let's say we had a positive number, right?
It could be positive or negative.
What would positive What would a positive times a positive times a positive times a positive be? Positive. What's
The bottom one's positive too.
Yeah.
the bottom one's positive too? So what's your answer?
No solution.
That's right. There's no way that I can multiply a number by itself 4 times to get a negative number. And if you guys remember, that's what this table up here was for. Look up here. If you have an even index and a negative b value under the radical, there's no real roots. So look, what is the index right here? 4. That's even, right? The number is negative, so there's no solution. That's what that table's telling you.
So it has to be positive.
Right, it has to be positive. For even index, it has to be positive to have solutions. So on number 2, what about this one? What do you do for this one?
It's 2 over.
Close.
2 over.
So you got to take the 4th root, right? Make sure you write this at first because that's what you're trying to find, okay?
2 over 3.
That's right. So it is 2 over 3. Nice.
Yeah.
And then what did you say? You said in front is plus or minus, right? Plus or minus 2 over 3, right? Because we can already see that. How'd you get 2 over 3? Because, yeah, 4 times,
Oh, okay. Yeah,
right?
You're multiplying across.
Yeah, you're multiplying straight across. Another way that you can think about this actually is, watch this, the 4th root. Exactly, you're right. 4th root of 16 over 4th root of 81. 4th root of 16 is, and 81 is going to be, and plus or minus because it's even. There you go. All right, number 4 now. What is each real number root? So now it's just kind of changing in between. On number 4, what is the cube root? Oh, the numbering's kind of messed up. Just ignore that. Number 4, what is the cube root of negative 8? What'd you say? 2.
No, it's not.
Negative.
That's right, it's negative 2 because 2 times 2 times 2 is 8. Negative 2.
Why'd you say 2.5? Like,
That was negative 2 is negative 8. So the answer is negative 2. All right, what about number 3?
Yeah.
You're multiplying a number by itself 3 times. 0.3, that is correct. Very good.
what? Oh.
Right. 3 times 3 times 3 is 27. How many decimal spots do we have? 1, 2, 3. So then we go 1, 2, 3 from each of the 0.3s.
Ow.
Very good. Okay. Number 2, because that's what the numbering says. What is the 4th root of negative 1? No solution. Good. Very good. No real solutions.
Negative 2. Wait.
And number 1. Let's see what you guys get for number 1. What do you think that one is?
So first we multiply.
Square root of the other.
That's right.
So that'll be square root
4.
of 4.
That's right. This is actually the square root of 4 because negative 2 times negative 2 is 4. So what is...
2 plus or minus 2.
Very good. Plus or minus 2. This one asks for each real number root. It doesn't say principal. It says real number, which specifically tells you to give plus or minus. Okay, so... Alright, this right here, this little box has a property, but that's kind of a little obvious. But let's go to the important part right here. When to use absolute value symbols. This is very important right here. So, this is when you're asked to give the principal root for a root that has variables in it. Notice how these radicans have variables in it. You see the x and the y and stuff like that, right? So let's see how we're going to use this to find the principal root. Remember, principal root means what? Positive solutions, right? So on number 1, whoa, what's the square root of 9x to the 4th? Do you know how to do this? You can take each term separately. So just find the square root of 9. What's the square root of 9? 3. Why didn't you say plus or minus 3?
This is the principal.
Thank you, because it says principal root. Okay? Now, what's the square root of x to the 4th?
X to the
X
fourth.
squared.
X squared, that's right, because, watch this, x squared times x squared. When you multiply variables together, you add the exponents. So 2 plus 2 is 4, right?
Yes.
And let me show you another way you can find it. What's the index right here? 2. To find out what the root is, you can just take the exponent on the inside and divide it by the index. 4 divided by 2 is? So it's x squared.
3x squared.
Right. Now here's the important part. You have to make sure this is a positive number all the time, right? Because it says principal root, right? So how am I going to check if that's positive? Well, watch this. X squared means that the number is going to multiply by itself, right? So if x was a positive number, what would this number come out to be? Positive or negative? Positive. If x was a negative number, what would it come out to be? So no matter what x is in this case, this is always positive, right? And does that satisfy the question that it's asking us? Yeah, so because it asks for principal root, it needs to be positive. So this one's right, good as it is. Nice. Let's look at number 2, though. It's the 4th root of x to the 12th, y to the 16, and Omar, you said you got the answer? What is it?
X, to their power.
How did you get that?
Because I just divided 12 and 16 by 4.
Exactly. You divide those exponents by the index. There you go. But now here's the thing. You see how y is being raised to the 4th, right? Well, an even exponent is always going to be... Why did I write negative right here? Whoa, hold on. Even exponent is always going to be positive, okay? Because if I multiply, positive, whatever, however many times, it's still positive. If I multiply a negative an even amount of times, it comes in pairs of 2, right? Which is always positive. But what about the x cubed? Look at the x cubed. If I choose a positive number for x in this case, what does x come out to be? Positive. But if I choose a negative number for x in this case, what does it come out to be? Negative. But that doesn't work because our question is asking for principal roots, right? That means our answer needs to be positive. So what can I add in my answer to make sure that it's always positive? Read the title right here. It's a hint.
Absolute value.
Absolute value. Remember, absolute value makes whatever's inside those bars a positive. So what do I need to put the bars around?
The absolute
straight
value.
line.
Which part though?
Oh, and the X.
On the x cubed, that's right. Because x cubed, oh no. X cubed is the term that could be positive or negative. So we want to make sure that it always comes out positive because we're looking for the principal root.
So the answer is like an odd. So
Exactly. When you have the even index and then you come out with the odd, right? Yeah, that has to be, you need the absolute value around there to make, that's when it's asking principal root though. Because principal root's asking for make sure it's positive. Otherwise it doesn't matter. So let's take a look at some examples and then we'll be finished over here. Example number 5. Simplify the following. For even index radicals, which of these numbers have even indexes?
First two.
The first two, because the first one is 2, the second one is 4. So for even index radicals, give only the principal root, which means positive. Good. All right, so number 1, what is the principal root of this? 4 x to the what?
So it'd be X to the 4th.
Why x to the 4th power?
Because you're multiplying 2 by
Oh no, it'd be 8.
It would be 8. That's right. If you,
I did 4
Wait,
by.
what was the
I did
eight?
cube by.
what is the index right here?
It's cube.
Wait, oh, it's cute. Okay, never mind.
It's a 2, right? Because you don't see it there. So then 16 divided by 2 is 8, and then 2 divided by 2 is 2, so you get x to the 8th y squared. Now, you notice how these are even exponents, which means that this answer will always come out positive. So we don't have to do anything with this. That's the answer. Let's look at number 2. The 4th root of 16, x to the 12, y to the 8, z to the 16. What would this be?
Would it be 2?
2, because,
2 to
right?
x to the third,
Right?
and then y to the second, and then z to the fourth.
Right. But now, do we need absolute values in this one?
Yeah, on the X.
Yeah.
On the x, why?
Because it's a 3, it's not.
That's for principal root.
Right. it's a 3 exponent. That means it could be odd if x was odd. But we want principal root. We only want positive answers. So we're going to make sure that it comes out positive by putting absolute values around it. Very good. And you got the 2 because 2 times 2 times 2 times 2 is the 16 that we see at the front right here. All right, last question. Cube root of negative 8a to the 6b to the 9th. What's that going to be? Negative 2. Good, because negative 2 times negative 2 times negative 2 is negative 8. And then what's the rest of it?
A to 17. A squared.
A squared, right? Because 6 divided by 3 is 2. And then? That's right. So this answer is negative 2a squared b cubed, and that's it. And remember, you don't have to worry about it because it only says give the principal root for your even indexes. That's an odd index, so that's good as it is. That's going to end these first notes. That was a long one, but until next time, see ya in the next one. Peace!